In April 2022, a United States Army general stood before the cameras and said something that Russian engineers considered impossible, that the new American rifle could fire a bullet capable of penetrating any modern body armor at 500 meters. It was not a boast. It was the result of a silent arms race that lasted more than 2 decades, and that began not on a battlefield, but in a cave in Afghanistan. It was October 2001. American soldiers from the 5th Special Forces Group were advancing through the mountains of Tora Bora chasing al-Qaeda fighters. Their M4 rifles fired 5.5 6mm bullets, the same ammunition adopted by the U.S. since 1963. At distances of 600 meters or more, between rocky hills and cold wind, the shots simply did not reach with enough force. The enemies knew this, and they retreated to safe distances, returning fire with AK-47s and PKMs that carried heavier 7.62mm bullets. Reports began to pile up. In Iraq, soldiers discovered that the M4 struggled to penetrate simple concrete walls. In Afghanistan, insurgents used vests captured from local security forces, and American bullets stopped in the Kevlar. A corporal from the 82nd Airborne Division described the problem with brutality. "We fired 2-3 shots, and the enemy kept standing. It was like throwing pebbles." The problem was mathematical. The 5.5 6mm bullet weighed only 4 grams and traveled at 940 meters per second. It was precise, light. A soldier could carry 210 of them, but its mass was too small to maintain energy at long distances. At 500 meters, it had lost more than 60% of its initial force. Against a level 4 ceramic plate, the type that the modern armies of Russia and China were beginning to distribute in mass, it simply crumpled on the surface. The American Army began to study the problem in 2017 with a classified document called Small Arms Ammunition Configuration Study. The conclusion was direct. The 5.5 6mm had reached its physical limit. There was no way to improve the ammunition within the same caliber to achieve what the military needed. A completely new cartridge was necessary. The requirement was specific and brutal. The new bullet needed to penetrate level 4 body armor plates at 500 meters. Level 4 is the highest protection available, designed to stop 7.62mm sniper rifle bullets and even .30-06 armor-piercing rounds. Never before had a standard infantry light weapon been designed with this goal. Engineers said it would require a cartridge operating at pressures that most weapons were not designed to withstand. In 2019, the American Army launched the Next Generation Squad Weapon Program. 7 weapon manufacturers were invited to compete. The requirement: to create a rifle and light machine gun system in a new 6.8mm caliber, capable of achieving muzzle velocities of 910 meters per second from a barrel of only 33 centimeters. For reference, this was comparable to the performance of a precision hunting rifle with a 61-centimeter barrel in a compact assault rifle. The company SIG Sauer, a Swiss-American manufacturer based in New Hampshire, submitted its proposal in September 2019. Its rifle was the MCX Spear, and its cartridge was the .277 SIG Fury, what the military would call the 6.8 by 51 millimeters. The innovation that made everything possible was in the bullet case. Conventional cartridges are made entirely of brass. The Fury used a hybrid 3-piece design: brass body, stainless steel base, and aluminum washer. The steel could withstand pressures of up to 80,000 psi, compared to the 65,000 psi that is the conventional limit and considered a safety threshold by the industry. 80,000 psi. To get an idea of what this means, it is the pressure you would find at about 5,600 meters deep in the ocean, inside a rifle cartridge. This pressure lasted only a few milliseconds. but it was enough to expel an 8.7-gram bullet at 914 meters per second from a 41-centimeter barrel. The energy at impact at 100 meters would be 3,426 joules, almost double what the M4 delivered at the same distance. Competitors were astonished. General Dynamics presented a polymer cartridge design. Textron Systems brought a telescopic cartridge system, but SIG's steel hybrid solved a problem that others couldn't: how to maintain the necessary pressure without the case exploding in the chamber. In April 2022, after 27 months of testing, the American Army announced SIG Sauer as the winner. The contract: 10 years, potentially 107,000 rifles, with the official name XM7, later reclassified as M7 in 2025. But there was a problem that American generals did not expect to discuss in public. The M7 weighed 4.45 kilograms with a suppressor, 2 kilograms more than the M4. Its magazine held only 20 rounds, compared to 30 for the M4, and each cartridge weighed approximately triple the 5.56 millimeters. A soldier who normally carried 210 bullets could now carry only 70 to 80. The question that ran through the halls of the Pentagon was direct: is it worth it? The answer came from a general who preferred not to be identified, quoted by the periodical Defense News: "When you pull the trigger once and the enemy falls, you don't need 210 bullets." The logic was the same that had driven every caliber transition in the 20th century. In 1942, the Allies adopted high-power 30-06 bullets because the Germans used vests. In 1963, the Americans changed to 5.56 millimeters because they needed more ammunition. In 2022, they were returning to the basic principle: power before volume. What made the M7 different from any rifle that came before was not just the bullet, it was the system around it. Paired with the M7 was the XM157 sight, developed by Vortex Optics, which integrated a laser rangefinder, automatic ballistic calculator, atmospheric sensors, compass, visible infrared sights, and a digital display overlaid on the optical view. It was, in essence, a combat computer attached to the rifle. The sight calculated distance, adjusted for wind, temperature, altitude, and presented the shooter with a corrected aiming point in real time. To understand what this meant in practice, imagine the following scenario. A soldier sees an enemy 400 meters away. With a conventional M4, he needed to estimate the distance, mentally adjust the elevation of the sight, and compensate for the wind. With the M7 and XM157 system, the rifle made these calculations automatically. Tests conducted by the Army Marksmanship Unit indicated significant reductions in engagement time and improvement in the rate of first hits against targets at distances greater than 300 meters. In March 2024, the 1st Battalion of the 506th Infantry Regiment of the 101st Airborne Division received the first M7S for operational use. In September of the same year, the 75th Ranger Regiment, the Army's elite rapid assault unit, began its own tests. The reports that leaked were uniform. Soldiers were impressed with the precision and the penetration capability. An officer from the 101st described the rifle as taking off a blindfold after years of shooting in the dark. The reason why the American Army developed a weapon capable of penetrating level 4 armor was never said out loud in official communications, but it was implicit in every classified briefing since 2017. The adversary that American military planners feared was not an insurgent using a Kevlar vest bought on the black market. It was a soldier from the People's Liberation Army of China or the Russian Armed Forces using the latest generation ceramic plates distributed on an industrial scale. China, in particular, had modernized its personal protective equipment aggressively after observing American wars in the Middle East. Its QGF-02 system, used widely by ground forces, incorporated boron carbide ceramic plates, the same advanced ceramic material that American forces used. A classified Pentagon study, part of which was summarized in declassified documents, concluded that in a high-intensity confrontation, up to 40% of potential casualties would be from combatants using protection that the 5.56 millimeters simply could not reliably penetrate. Russia, for its part, had invested significantly in new vests after the disasters of the First Chechen War, where Russian soldiers suffered heavy casualties due to inadequate protection. The 6B-45 vest, standard for Russian mechanized infantry, used SAPI-type ceramic plates rated to stop 7.62 millimeters armor-piercing bullets. The same vest that had saved countless Russian lives in Syria and Ukraine was what American planners needed to ensure the M7 could defeat. In May 2025, the American Army granted the M7 its standard type classification, the formal recognition that the weapon met all operational, safety, and sustainability requirements. It was a historic milestone. For the first time since 1963, when the M16 was adopted, the standard rifle of the American infantry changed fundamentally, not just the model, but the caliber, the combat philosophy, and the technology integrated into the system. In February 2026, soldiers from the 25th Infantry Division conducted training with the M7 at Schofield Barracks in Hawaii, supervised by instructors from the Army Marksmanship Unit. It was a visible sign that the transition had moved from paper into the combat ranks. The Army planned to acquire more than 107,000 M7 rifles and 13,000 M250 light machine guns, the automatic counterpart also developed by SIG over the next decade. But while the M7 advanced to the American front lines, a silent debate occurred in Allied military academies. The U.S. Marine Corps, with its own traditions and budgets, resisted the transition, preferring to keep the M27IR in 5.56 millimeters. NATO, whose forces operate with standardized ammunition, watched with concern. The M7 fired a cartridge that was not compatible with any other weapon in the alliance. If an American platoon ran out of ammunition next to German or British allies, there would be no way to resupply. It was the same dilemma that had paralleled all great armament revolutions. When the British adopted the Lee Enfield rifle in .303 in 1895, other Commonwealth members took decades to synchronize. When the U.S. introduced the 5.56 millimeters into NATO in 1980, Europeans resisted for years before standardizing. The history of military innovation is always the same. The power of new technology exists in constant tension with the weight of existing infrastructure. In September 2025, SIG Sauer presented an improved version of the M7 at the DSCI exhibition in London. The new model was lighter, 3.4 kilograms without optics, compared to the 4.45 of the original, with the barrel reduced from 26 to 26.7 centimeters and lighter internal parts. It was the direct response to the most common criticisms from soldiers: weight and volume. SIG had listened to the battlefield and adjusted the design. Brigadier General Phil Kinneary, commander of the Army Infantry School at Fort Benning, synthesized the philosophy behind the M7 in a phrase that quickly became quoted in military circles. The 6.8 millimeters stops the enemy with one shot. The 5.56 millimeters required several. It was simple, it was direct, and behind this simplicity was decades of lessons learned in Tora Bora, Fallujah, Mosul, and hundreds of smaller engagements where American infantry had discovered the limits of the ammunition they carried. But the story of the M7 was not just about a rifle. It was about a strategic equation that had changed. For 40 years, the U.S. had fought mainly against adversaries without advanced armor. guerrillas in Vietnam, insurgents in Iraq, militias in Afghanistan. The 5.56 millimeters had been suitable for these conflicts. But the 2020s signaled a possible different era of confrontations with powers that had modern defense industries, with soldiers equipped as well as Americans or better. Russia had demonstrated in Ukraine from 2022 that it could not sustain a modern military campaign with obsolete equipment. But there were lessons about ceramic armor, drones, and direct fire systems that all the world's armies were absorbing simultaneously. China, in turn, had not yet tested its forces in real combat since 1979, but had invested more than $200 billion per year in military modernization during the last decade. It was this scenario that the M7 was designed to face, not the war that America had fought, but the war its planners feared could come. A battlefield where both sides would use level 4 protection, where drones would observe every movement, where infantry combat would happen at distances of 400, 500 meters between well-trained, well-equipped, and well-armed soldiers. A rifle that could not penetrate the enemy's armor would be equivalent to having no rifle at all. General George Casey, former Army Chief of Staff, once said that America always trains for the last war. The M7 represented a rare attempt to do the opposite, prepare for the next. A weapon developed not based on the enemy that soldiers had faced in the last 2 decades, but based on the enemy that analysts and planners predicted for the next 2. In March 2024, when the first soldiers of the 101st Airborne Division at Fort Campbell held the M7 for the first time, few of them knew they were carrying the product of 20 years of lessons learned, from the mountains of Afghanistan to the classified briefing rooms of the Pentagon, from SIG Sauer's metallurgical laboratories in New Hampshire to the production lines that assembled the most advanced hybrid steel and brass cartridge ever mass-manufactured for an infantry rifle. The M4 rifle that the M7 replaces had served for more than 30 years. It had been used by more than 1 million American soldiers in more than 20 countries. It was a reliable, precise, and familiar weapon, but the world it was designed to defend had changed. And so, in silence, without military parades, without major public speeches, the United States Army initiated the largest individual armament transition in 6 decades. A 6.8 millimeters bullet traveling at 914 meters per second. A pressure of 80,000 psi inside a hybrid steel and brass case. And the promise that this time, when the American soldier pulled the trigger, the enemy's armor would not be an excuse.